Hi there. I'm going to work out number 104 from Chapter 2. 104 says, at the 18th green of the U.S. Open, you need to make a 20.5-foot putt to win the tournament. So, you are over here, maybe with a golf club, and you need to make it into the hole over here. And from you over to the hole is 20.5 feet, which we don't like to leave that in feet. We're going to have to change that to meters. When you hit the ball, you're giving it an initial speed of 1.75 meters per second. What did they say? 1.57 meters per second. It stops 6 feet short of the hole. Dang it. All right. So from here to here is 6 feet. Okay. A, assuming the deceleration caused by the grass is constant, what should the initial speed have been to just make the putt? Okay, so we are interested in a new initial speed. I'm going to call that V initial prime because it's a new one, is equal to what in order to have our displacement be equal to the whole distance. Well, since we're doing that, I think I'm going to change this feet to meters. Look in the front of the book, and 1 meter is 3.281 feet. 3.281 feet is 1 meter. So find a calculator somewhere. And 20.5 divided by 3.2, dang it. 20.5 divided by 3.281 equals 6.25. That is my total displacement that I would like to have. All right. 6.25 meters for that situation. And here's the problem. We don't have enough variables. So what we need to do is we need to figure out the acceleration experience as it goes across the grass based on the situation that we do know, which is this velocity and that distance. We have, and because in that situation we know that the final velocity is equal to 0. So in order to find that, I am going to put that on the back burner for a second, and I'm going to say V initial is equal to 1.57 meters per second. That is the case when my displacement is equal to 6.25 meters. Oh, dang it, I need another one. 6 feet, same conversion, 3.281 feet, 1 meter. 6 divided by 3.281 is 1.83. 1.83. Looking back at the problem, it said 6.00 feet, so I do get 3 sig figs. 1.83 meters, so that means that this displacement is 6.25 minus 1.83, and so it's 4.42. 4.42 meters, and V final is equal to 0. All right, with those things, I can find my acceleration. So I'm going to use the fourth kinematic equation because I don't have time. So V final squared equals V initial squared plus 2 times our acceleration times our displacement. The final velocity is equal to 0, so that goes away. The acceleration under these conditions is equal to the negative V initial squared when we subtract it to the other side. Then we have to divide by 2 and by delta x to get it isolated. Now we plug in numbers. Negative v initial we said was 1.57 meters per second squared. Make sure the negative is outside the squared variable. Divided by 2 times our displacement, which we decided was 4.42 meters. So our acceleration, 1.57, square that, divided by 2, and divided by 4.42 is 0.279. Negative 0.279 meters per second squared. All right, now with that, we are going to return to our initial situation. We're going to bring these guys in on the picture. And we know that if you were to make it into the hole, once again, your V final would be equal to 0. And again, we do not have time, so that means we're going to use that equation again. V final squared is equal to V initial squared plus 2 times the acceleration times our displacement. This time, well, we still have that being equal to 0. This time we're solving for V initial. So V initial is equal to the negative, got to move those to the other side, negative 2 times our acceleration times our displacement, and then that quantity square rooted. All right, so negative 2 times negative 0.279 meters per second squared multiplied by delta x, which for the entire trip was 6.25 meters, and then that mess all gets square rooted. So V initial is equal to plus or minus 2 times 0.279, I ignored the minuses, they're going to cancel out inside, times 6.25, square rooting that, 1.87 meters per second, and this is the positive direction, that's going to be the negative direction, so we're going to call that positive. So 1.87 meters per second is our final answer for part A. All right, so that's our answer for part A. For part B, they would like to know what initial speed you need to make the remaining 6-foot putt. That's actually quite easy because we just set it up. We're going to do the exact same thing we did, but now our displacement is going to be the 6 feet. It's going to be 1.83 meters. Well, there's a slight difference. For the remaining putt, no, I take that back. There is no slight difference because we're still going in the positive direction, so everything is the same. So for part B, the V initial for the second shot, so I'm going to put a sub 2 there, is equal, I've already solved it before, so I'm not going to resolve it, negative 2 times the acceleration times the displacement for that second shot. All right, so negative 2 times negative 0.279 meters per second squared times the displacement of 1.83 meters. Square root that mess, and V initial 2, and it's going to be positive, we already know that. 2 times 0.279 times 1.83, so we get 1.02. 1.02 meters per second, which is the final answer for part B. That's it for number 104. Thanks for watching.